G'day Bifrosters. Let's try and take the mystery out of some loops, shall we? Let's start with the for loop for each. So here's what we're going to do. I'm going to make a sphere. Not a sphere field, sphere, create mesh sphere. I'm going to plug it into this. I'm going to use this loop to create a number of spheres. Big thanks to Stefan on the Slack channel for that. For giving me the idea, which I'm now blatantly stealing, but it's a good way to show loops. So we'll do these loops as 3 different episodes or videos, just quick ones. First one we're going to do is for each. Things you remember about for each is that it runs in parallel, so it does all of the loop at once. Okay, this means that there's some things we can't do in it, but we can do this in it. So let me show you how this works, and hopefully we'll get a bit of insight, because I know a lot of people have trouble with loops in Bifrost. So we have a mesh sphere. It's radius of 1. It's pretty much, we just might as well make it a little bit more high res. I'm going to throw an output over here, but I'm not going to show anything yet. Nice blank screen. So we jump into the loop and we've got a bunch of things going on here. We've got max iterations, current index, and whatever we've put into it. The max iterations is quite simply the number of times you go around the loop. You can, if you want to, delete this, and this will just loop through however many things you put into it. We don't want to delete it for this one though. First thing I'm going to do is I'm just going to try and get a certain number of spheres. So for that we'll use translate points. Here's our points coming in. There's our points going out. And you notice this little symbol here? This is basically saying, okay, this is now a port iteration target, which means this is what the loop is operating on. So what I want to do is I want to use the current index of the loop. And what this does, what the current index is that every time around the loop, this changes by 1. It's a nice, handy use of a changing value in Bifrost. And what I'm going to do with it, I'm going to turn it into a float for a start, because I want to do things with the float, and I'm going to make a value. Let's see. This value is going to be how many units between our spheres, and I think with a sphere of 1 with a bit of distortion on it, I think 3 is going to be a good number. So what I'm going to do is I'm going to take this and I'm going to multiply it by the current index. And what that means is on the first time through the loop, the current index is 0. 3 multiplied by 0 is 0. And then if I take this guy and I'm going to pop him into a value, again, Bifrost, why do you do this to me? Throw that into a vector value, like this. And I'm just going to put that into the X, and then use this as my translation. Okay, so on the first time through the loop, that index will be 0. 0 multiplied by 3 is 0, which means this value, my translate value, is 0, 0, 0. Goes to the sphere, which is coming in from here, translates it to 0, 0, 0, and then outputs it. Then goes back around the loop again. So the second time round, the current index is 1. 1 times 3 is 3. So 1 multiplied by 3 is 3. This becomes 3, 0, 0, because 1 multiplied by 3 is 3. 3, 0, 0 gets translated, and out it goes. So we can see the result of this, and so on until we run out of iterations. So I've got this set to 10. Let's put this out here, and what you can see, let's count them. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spheres in a line. And if I was to go to my top view, change my background, go to wireframe, 1, 2, 3 units apart. And if I now go up here and I go to my max iterations and I change that to 2, I'm only getting 2 spheres, but they're still 3 apart. So that's the basis of a for loop. We'll just do something a little fancy as well. Let's throw in a curl noise field. And what I'm going to do is as well as translating the points, I'm going to displace the points. And I'm going to displace the points with this curl noise field, like this. And you can see it's displaced, and they're displaced differently because they're in different places in the field. So this means if I change this back to 10, you'll get a different displacement, because remember, a field is something that permeates the whole universe and has a bunch of vectors and things going on. So we're displacing this sphere every time we go around the loop by this field, and because we're in a different place in the field, or a different position, because this is at 0, 3, on the X, 0, 3, 6, 9, 12, etc., we're picking up a different displacement from the field each time. Now, if we really wanted to get cool with it, I could take the current index again, and I could just put that into the field seed. And now it's changing the field every time through. And you can see you've gotten some different displacements. If I break this and put it back, you can see that happens. So that is a for loop. So the next video we'll do will be the iterative loop, or iterate, which is a lot like a solver. It has a few differences, but it works a lot like the solver. All right, so I hope that's helped, and I'll catch you next time. Thank you very much.